Hello students, I am Dr. Ramsun Lodhi from Applied Science Department. So in this semester, I am going to teach you discrete mathematics and probability theory. So welcome to you all in this subject. So today I am going to discuss the first unit. So first we will discuss the content of the first unit. So our module name of the first unit is a set theory, and it contains the set, combination of set, Venn diagram, finite and infinite set, cardinality, principle of inclusion and exclusion. So today lecture we will discuss the definition of set, representation of set, and types of set. So first we will discuss here what is the set. So in study lecture I have already discussed about the applications part of the set theory. So sets are used to define the concept of relations and functions. The study of geometry, sequence, probability, etc. requires the knowledge of set. The set theory was developed by German mathematician George Cantor, and he had developed the concept of set theory in 1874. So answer of our first question, we have asked what is a set. So a set is a well-defined collection of objects. So what is meaning of well-defined? So well-defined is a adjective, means that we should be able to determine if a given element is contained in the set under scrutiny. Okay, so the objects in the set are also called the elements or members of the set. Means the set will denoted by uppercase letter, means capital A, B, C, X, Y, Z, etc. And the elements are denoted by small case letter A, B, C. And set is also denoted by in curly bracket, means this. Okay. And here I have taken the example S equals to S is a set and X, Y, Z is a element, is a set. So here X is an element of the set S, or X belongs to S, and it is represented by X belongs to S. And if any elements which not include in this set, so in mathematically it is written as not belongs to. So similarly, if I write here A not belongs to it, it means A is not an element of this set. So other example of sets, pupil in a class, means we have taken here the collection of students in a class, pupils in a class. So we have taken a few names, Abhishek, Kunal and Chetna. We can also take all some other names, means we can also take the collection of students in C division. Okay, so it is a set. Course offered by the departments. So I have taken here the few selected subjects: Indian mathematics first, second, DMPT, M3 and so on. Color of rainbow: violet, indigo, red, orange, yellow, green, blue. These are the examples of set. States of matter: so solid, liquid, gas, plasma. Set can contain non-related element, means here in this example we have taken the set contains a number 3, alphabet A, red color, and DMPT is a course. So set contain non-related element. It is not mentioned, it contains only related element. Okay. So another example, all positive number less than or equals to 5. So we have taken here 1, 2, 3, 4, 5. This is an example of set. A few selected real number, means 2.1, pi, 0, minus 6.32 and pi. These are the example of the sets. In the set, order does not matter. If you look at here, so I have written here 1, 2, 3, 4, 5, and also written here 3, 5, 2, 4, 1. So in the set, order does not matter. Okay, means both are equal. Often used sets, here is also Standard notation of this set means capital N is a notation of natural number set, and it is starting from 1, 2, 3 and so on. And whole number is denoted by the W, and it starts from 0, 1, 2, 3, 4, 5 and so on. And the set of integer number is denoted by capital Z, and it is here is written minus infinite to plus infinite. Z plus is the set of positive integer. Okay, and Q is a notation of set of rational number. Means when you write the integer in P by Q form, so that number is a rational number. And but you have to remember Q does not equal to 0. And Q star is the set of non-zero rational number. And R is a set of real number. R plus denote the set of the real positive number. R star is the set of non-zero real number. And C the set of complex number. Set properties. So set do not have duplicate elements. Okay. So if you take here the example vowels of alphabet. So when we make the list, so we can write like this: A, E, I, O, U. But when we make the sets only, so you have to write like this only: A, E, I, O, U. In the set, elements are not repeated, but list you can repeat the any elements. And also you have to remember in the set order does not matter, but the list order does not matter. So but in this course we will not more study about the list, we will only focus the set theory. So we have also taken here some other examples of set. So S contains set curly bracket 1, curly bracket 2, curly bracket 3, and this is also example of set. Here T, here we have taken the 1 curly bracket inside 1, here 2 curly bracket, then inside 2, here 3 curly bracket inside 3. So when we apply the curly bracket in different elements, it all the distinct, not all the same. So if I write 1 curly bracket 1, double curly bracket, triple, all the elements are distinct. Representation of set. There are two ways to represent the set. Number first, roster form or tabular form. In this form, all the elements or members of the set are listed, then the element being separated by commas and are enclosed in braces. Here you can see the example: the set of odd positive integer less than 12 can be written in this form: 1, 3, 5, 7, 9, 11. Another example: set of all vowels in English alphabet can be represented by A, E, I, O, U. Another notation is set filter form. So we define the elements of this set by specifying a property that they have in common. So if you look at, I have taken as example S consisting of elements A, E, I, O, U. So this set can be written by in the set filter form, means X such that X is a vowels in the English alphabet. Means when we represent the set in set filter form, so all the elements have same type property. So if you look at here, here is also another set is given S equals to 1, 4, 9, 16, 25. So we can write this set in set filter form. So we can write here X such that X equals to N square. N is a natural number less than or equals to 5. Now I am going to discuss types of sets. So first is an empty set, or it is also known as null set. A set with no elements is called an empty set or null set or void set, and it is denoted by phi or only curly bracket. Okay. So here we have taken the example of the null set. X such that X is a real number satisfying X square equals to minus 5. So when you find the root of this equation, so you will get X equals to plus minus 5 into iota. Okay, so this is a complex number, so means there is no root in the real number, so this is a null set. Similarly, if you look at here the another example, X says that X is an integer satisfy 3x plus 5 equals to 6. So when you simplify, so you will get X equals to 1 by 3. So 1 by 3 is not an integer number. Okay, so that's why this is example of empty set. Singleton set. A set consisting of a single element is called a singleton set. For example, you can see here S equals to only it contains the 3. Another example, x such that 1 is less than x is less than 3 means x is greater than 1 and less than 3, and x is a natural number, so there is only one element 2. So this is a example of singleton set. Finite set, a set which contains a finite number of elements is called a finite set. So look at here the example, a equals to 1 2 3 4. So this is the example of the finite set. Similarly, you can also check the example b. This is a similar of the a. Okay, in the set of students in a class, it also the example of the finite set. Infinite set, a set which contains an infinite number of elements is called an infinite set. So here you can take z equals to x such that x is an integer. So this is an example of infinite set because set of integer number includes infinite number. Second example is also a example of infinite set. If you look at here, so s is a x such that x is a real number. So x is greater than or equals to 1 and less than or equals to 4. So when you find the real numbers, you can write 1, 1.1, 1.2, 1.3 and so on. So this set contains infinite number of elements. So this is the example of infinite set. Universal set, the set which contains all the objects or elements under consideration is called the universal set, and it is denoted by capital U in italic form. Okay. Here is the example for the set this -2 0.42. So in this case u would be the real number. Okay, so again one example I also mentioned here 0 1 2 3. In this case universal set would be maybe whole number, maybe integer number, maybe rational number, depends on the context. Okay, for the set of vowels of alphabet u would be all the letters of alphabet. Another equality or equal set, two sets are equal if they have the same elements. So if you look at here this and this, because in the set order does not matter. So these are the example of equal set. Two sets are not equal if they do not have the same elements. So if you look at here this example and this, so this set includes 1 2 3 4 5, but this set only includes 1 2 3 4. Okay, so these are the not equal set. Subset, let S and T are two sets and all the elements of a set S are also element of the set T, then S is a subset of T. So if you look at the example here, so S is a 2 4 6 and T is a 1 2 3 4 5 6 7. So all the element of our set S is also in the set T, so that's why S is a subset of T. So it is denoted by S is a subset of T. Okay, so if S is not a subset of T, then it is written as S does not a subset of T. So you have to also remember for the subset, every set is a subset of itself. The empty set is a subset of all set. And if the set contain n elements, then the number of subset is 2 to the power n. For example, if you look at here, S equals to A, B, C. So here is a 3 elements. So the number of subset is 8. And when you find the subset of this set, so here is a 5. Empty set is subset itself, A, subset B, C, AB, BC, AC, ABC. These are the subset of the set S. Proper subset. Here are two sets S and T. The set S is called the proper subset of T if and only if every element of S is the element of T and there is at least one element of T which is not in the element of S. So proper subset is denoted by this. And we have taken as the example T equals to this 0 1 2 3 4 5 and S equals to 1 2 3. So S is not equals to T and S is a subset of T, then S is a proper subset of T. And also we have taken the one more example, R equals to 0 1 2 3 4 5. So R is equals to T, so R equals to T and thus it is a subset but not a proper subset of T. So we can write here that R does not proper subset of T. I have also taken one more example, Q equals to 4 5 6. So Q is neither a subset of T nor a proper subset of T. So guys, in this lecture we have studied the definition of sets, types of sets. So thank you for watching this lecture and we will meet in next class. So thank you and bye bye.